be enlarging, reducing, rotating, reflecting. Sometimes I even wonder if I need to do formal notes with this because I feel like you could probably handle it, okay? So that's really just what this is talking about, what we just went over. So again, not all the figures will be congruent today because if you have to do a reduction or enlargement, clearly that will change the size. All right, let's just get to it, right? So graph segment CD, obviously we know how to graph it. Don't forget, we've talked about this in the past. Do the transformations in the order they give them to you. So I'm going to start plotting C at -2, 2. Label, of course, right? Label. D at 2, 2. So there's my segment. Okay, in order. From the purple segment, I'm now going to do the green. Now, you might need your formula sheet for this. I've got it on here. So 90 degrees, remember your rotation formula is that -b, comma a. I'm just going to jot it down. So I'm going to make the coordinates for that. So C prime. So remember, you have to switch the order on it and change the sign on the second coordinate. So I'm going to have -2, -2. We'll plot that in just a sec. D prime. Let me give you a second. You tell me what's the coordinates for D prime. Who's got it? D prime. -2, 2. I heard it. Perfect. Because remember, you're going to switch the order and change the sign on that second coordinate. That's supposed to be a parenthesis there, a sloppy parenthesis. All right. Question for you. Can I change the size of the segment?
No.
Not yet, right? Okay, let's plot it -2, -2. We're going to label -2, 2. Label. All right, so they share a point there. That's okay. That can happen. Not worried about it. Now, from the green, we're going to do the blue. Because remember, we don't back up because I still have some kids that back up to the original. Remember, one transformation leads you to the next. So from my green coordinates, I'm going to do the dilation. Now, question for you, doesn't ask you to write this, but we should recognize it. What's your scale factor? 1/2. So is it going to enlarge or reduce? Reduce. So we're going to have a smaller segment. So I'm going to make C double prime, D double prime. And I think we don't need a calculator for this. We just have to multiply all of this stuff by 1/2. What's -2 times 1/2? What's half of 2? 1. So -1. Half of that again. Half of -2. Half of 2. Okay, plot it. My segment should be half the size. -1, -1. C double prime. Got it. So, have I really taught you any new skills whatsoever in this problem? Absolutely not. Okay, it is just a combination, a free-for-all. You've got to do it all. We're going to do it all in these problems. Any questions on the first one? All right, flip it. Love the enthusiasm. Okay, let's do the triangle. Oh, reflection this time, reflection, and a dilation. Okay, we got it. So same thing, I'm going to plot my vertices. I'm going to label, of course. So there's my F. G's at 4, 4. And H at 2, 0. Perfect. Okay, I'm going to do the reflection in red. Now, reflection, of course, on the x-axis. There is the formula for it, but honestly, I don't even need the formula for this. I'm just going to count. First, I'm going to put my dashed line of reflection here in red. And I'm just going to count how many units I am from that line of reflection. Now, I'm going to start with the easy one, H. H is right on the line, so where is H prime?
H prime is the same.
Yeah, same thing. H prime. Okay, let's do F. So F is 2 above my red line of reflection, so now I go 2 below. F prime. And then G, of course, 1, 2, 3, 4 above, 4 below. G prime. All right, make your triangle, of course. Now, I'm going to write down the ordered pairs over here because I know some of you like the formula. So F prime, of course, that was our 1, -2. My H prime stayed the exact same ordered pair. That was the 2, 0. So again, if you like the formula over here, A -B, I mean, you could do it off of that too. So 4. So if you like the formula, there you go. Okay. Now, the red triangle leads me to the blue. So dilation. I know it doesn't ask, but humor me. What is your scale factor on the dilation? 1.5. So enlargement or reduction? Enlargement should be bigger. Now here's where you might need your calculators out, because I said I don't know how great you are with decimals, no judgment on that one. So to make f double prime, we have to multiply all of these red coordinates by 1.5. Well, some are going to be easy. 1 times 1.5, I got that. Now, is that going to be difficult to try to kind of estimate 1.5 with my lack of artistic skills? Sure, but I'm going to do the best I can. What's negative 2 times 1.5? Negative 2 times 1.5. Negative, I think I heard it over here. Who said it? I heard some different numbers here. Okay, what's 2 times 1.5? 3. Okay, this is easy. 0 times 1.5. Let's do our G double prime. Okay, I might need your calculator for this. What's 4 times 1.5? 6. And then we'll have negative 6. All right, plot. Estimate the 1.5 best you can. It's not going to be perfect. We're just going to do it. 1.5, that looks good right there. 1, 2, 3. F double prime. 3, 0. H double prime. And then 6, negative 6. Got it. G double prime. Okay. And my triangle does look enlarged. 1.5 times the size. I like it. So once again, have I really taught you anything new? No, sure haven't. Sure haven't. And remember, this is why we call vocabulary similarity transformations. Your final one, not congruent. We're changing the size on it, so that's why we switched the vocab to similarity. I know it's very fancy. All right, let's do another. Because we have not done one of these in a while. I know you know how to do it, but we just haven't done one, so let's practice that. So let's, of course, mark your triangle. Here we go. So plot your points. Got it. F, negative 2, 2. G, negative 2, negative 4. I kind of miss proofs. Negative 4 for H. All right, get your triangle drawn. Got it. Okay, I'm going to do this guy in green. Now, just because we have to do a dilation at the end, I'm also going to, because I have a feeling I'm going to need the ordered pairs here for my green triangle, so I am going to go ahead and write down like F prime, G prime, H prime as we go here. Now, most of you can look at this and you can just very simply move the triangle. If you have plus 3 on here to X, that means you're moving it 3 which way?
Right.
Right. 3 right. And the plus 1 on the Y moves it which way? Up 1, yeah. Now, can you guys just 3 right, up 1? Sure. 3 right, up 1. Sure. Do it. 3 right, up 1. But I have a feeling I'm going to need the coordinates, so I'm also going to make those. I'm going to add the 3 and add the 1 to each of these. So negative 2 plus 3. 2 plus 1. I'm going to add the 3, add the 1. So I'm going to have 1, negative 3. Same thing to this. I'm going to add 3, add 1, because I think I'm going to need these ordered pairs to get me to the dilation. Now, again, choice. Plot the points, draw it, or just move each vertex right 3, up 1. And that is where F prime is. Okay, I'm going to do H, right 3, up 1. And then G, right 3, up 1. Now, normally I wouldn't have bothered writing the coordinates. I would just do up 3, right 1. But because I see this coming at me, it's like, ooh, I'm probably going to need the coordinates. Okay, what's your scale factor on the dilation? 2, so it should be double the size. We're just going to times all of these by 2 now. Well, that's easy. Okay, double all of that. 1 times 2, 3 times 2. Got it. 1 times 2, negative 3 times 2. Let's do H double prime. What are your coordinates for H double prime? Too easy, you got it. All right, let's plot it, draw it. Our triangle should be double the size. 2, 6. F double prime. 2, negative 6. Negative 2, negative 6. Yeah, this this is like a bad coloring page. Any questions on that guy? You recheck this to mark theirs. And again, make sure you're labeling all the vertices. I know I keep harping about it, but you know, I still have kids not labeling the vertices. That's why I keep harping about it. So again, nothing new. I love this section because we just kind of get to practice a little bit of everything. So really, last thing, more practice. Here we go. So let's just take a look at these to make sure we can look at the pictures and we know how to do our scale factor, our fraction. So it says for each of the following, find the scale factor, tell whether it's a reduction or an enlargement. Remember we use the variables k for the scale factor. So remember, you have to know, is it 6 over 14 or 14 over 6? That's what you have to know. You count from the center to the prime first, the image first. So I'm looking at the 6 first, because that would be the image. The prime notation is the image compared to the pre-image, what you start with, which is the 14. And of course, all good mathematicians that we are, can you reduce 6 over 14? Sure can. To what? Perfect. The last thing, if your scale factor is 3 over 7, enlargement or reduction? Reduction. Okay, you can just put R or E for it. All right, let's do this, guy. So same thing. It's always kind of that 50-50. Is it 9 over 24, 24 over 9? You tell me. Remember, you go to the prime first. Perfect. Does 24 over 9 reduce? Yes, 3 goes into both of them. How many times does 3 go into 24? 8. And of course 3 goes into 9. Okay. Enlargement or reduction? Enlargement. 8 over 3 is definitely over 1. I'm just going to put E for enlargement. You can too. All right, let's look at the next pictures. I couldn't fit them all in one slide. So same question. 15 over 9 or 9 over 15? 9 over 15 to the prime first. Reduce that for me. What's 9 over 15? 3/5. Enlargement or reduction? Reduction. All right, final one of these guys. Same question as always, 8 over 28 or 28 over 8? 28 over 8 to the prime first. Does that reduce? 7 over 2. Enlargement or reduction? Enlargement, because that's clearly over 1. That's about 3.5. 3.5 times the size. We got it. All right, any questions on those? Only reason we're doing one more is because, hey, I got fancy and threw a percent in. Get excited. Graph the polygon with those vertices. Okay, let's graph it. And then it says your scale factor. Oh, that's fun. 120%. Okay, we'll get to it. So A, 0, 5. 1, 2, 3, 4, 5. Got it. Oh boy, B, -10, -5. I was very quietly counting there. And C5, -5. Notice I gave you a big graph grid on this one. I give you a sec to get all those marked out. And label, of course. Label. Every time I do that straight. Okay, scale factor, 120%. First question, enlargement or reduction? Enlargement, it's going to be bigger, 20% over. Now, when you make your coordinates, most of you, a lot of you using graphing calculators, myself included, those do not have percent keys on them. You cannot hit times 120% on your calculator. You have to know what is that as a decimal. 120% is the same as what decimal? 1.2. So we are going to multiply all of these by 1.2. Probably need your calculator for that. Well, maybe not the 0 here. 0 times 1.2, we got it. What is calculator? What's 5 times 1.2? 6. And I'll be honest, I mean, you got to kind of use your calculator for that. B prime. What's -10 times 1.2? -12. Notice these are all bigger. They should be, right? What's -5 times 1.2? I'm really excited to count that one out with a -12 in it. Okay, C prime. 5 times 1.2. 6, and then we'll have negative 6. Okay, so it should be 20% bigger than this triangle, so a little bit bigger. Let's see how it looks. So 0, 6. Well, this was 0, 5, so I'm just going to go one above it. Saves me a little counting there. Oh, God, negative 12, 6. So negative 10, 11, 12, 3, 4, 5, 6. Okay, C, 6, 6. Now clearly I'm going to connect the blue dots here in just a quick second, but we know my drawing skills. Does the blue, mine's in blue, does the second triangle look about 20% bigger than the first one?
Yeah.
Yeah, we'll go for it. Okay, let's see what, oh boy, that wasn't very straight, kids, work with it. There we go. So really, when you look through the notes today, did I teach you anything earth-shattering, new material? No. It's just a combination of everything together, my friend.